Okay, then we are ready to go today. Good morning or good afternoon to everyone joining from around the world. Very happy to see you all here for this webinar from Nordic Semiconductor. In today's webinar, we will do an overview and introduction on the nRF9160 Cellular IoT device from Nordic, and also highlight a few of the latest improvements or additions to the feature set. My name is Christian Sæther. I am the product manager for Cellular IoT in Nordic, and very pleased to be able to present to you today. Before we get going on the detail, just let me cover a few practicalities with regarding the webinar itself. I will try and keep my speak to around 15 minutes and then have a few minutes left in the end for answering as many questions as possible. So please ask questions. Please try and keep them relevant for the topic today. You should know that if you go to the question tab in the top right corner, all the questions you ask there are anonymous, while the chat is not anonymous. So if you wish to stay anonymous, please use the question tab. And it's also easier for me in the end to see all questions if you all use the question tab. If there is a lot of questions that are not relevant or there's not time to answer all the questions today, encourage you to go to DevZone, Nordic Semiconductor DevZone, which is our public place for technical questions and support, where we answer everyone that gets in there and have questions for us. So when presenting the nRF9160, I always like to begin with this overview. When Nordic decided to build our first Cellular IoT solution, we, from day one, want to focus on solving three big challenges that still persist in some way in the Cellular IoT market. First of all, we wanted to create the lowest power LTE-M and narrowband IoT chipset out there, since almost all Cellular IoT devices are battery powered, and power consumption is really key to realize a lot of the promised small Cellular IoT applications that need to operate for many years in the field without the need for changing or replacing the batteries. We did this by building everything from scratch with this low power target in mind from day one. We selected memories, process technologies, and IPs that enable this to be very, very low leakage in sleep mode. And we selected an architecture that did super optimized clock and power management between modem and the application side. The second goal was really to make Cellular IoT easy to use. Not only for a few big ones out there in the market, but for all of you thousands and thousands of customers to take a device and build your application almost on your own to realize hundreds of different applications. So very, very versatile solution. We have done this by putting all our development tools, all our documentation online for everyone. We focus a lot on the software stack and the middleware, and we focus to building complete application examples that all are open source. So you have an excellent starting point for your complete applications when you want to add cellular connectivity to what you're doing today or what you want to do next. All the kits and devices are sold through distribution with coverage around the world. So it makes it very easy to get hold of evaluation kit and devices. And even though we have come a long way on ease of use, we are not done yet. We continue to improve by simplifying the toolchain installation, simplifying our documentation, simplifying how you get connected to the network, and more. The third big goal for us was to create an unprecedented level of integration. We did this by making a complete communication and application module with all the relevant components included. We used chip packaging or system in package technology, and the result is that we created a really small 16 by 10 by 1 millimeter package, which is very easy to integrate on a PCB. Here you can see that 16 by 10 millimeter system in package that we have, which is the 9160 product from Nordic. The core of this product is Nordic's own developed system on chip. So inside the SoC, there is a system on chip that also comes from Nordic, and around it, almost everything you need in order to realize a low power and highly integrated cellular application. So if we take a glance inside this system in package, we have the nRF91 chipset from Nordic, which contains both the application processor built around an ARM Cortex-M33 microcontroller and the modem, which supports LTE-M, narrowband IoT, and GPS. Power management, passives, crystals, and RF front-end is also included in the package. And because we have built the complete solution ourselves, we ensure that all the clock, all the power management, all the sleep management between the modem and application is optimized for low power. So we are able to achieve 19 microamp average current during a 1 minute 20-second EDRX cycle, covering both the application processor and the modem power consumption. This SoC has multiband support, so it can work in all parts of the world with all the key bands that are used around the world today. And we have pre-certified this system in package, both with regard to regulatory and with regard to carrier certifications. And I will show an updated status of all our certification at the end of the presentation. So if you start then looking at the connectivity part or the modem part of the 9160, this is a modem supporting LTE-M, narrowband IoT for worldwide operation, built from scratch to achieve low power. Built from scratch means that Nordic doesn't have any legacy IPs such as 2G or Cat1 and so on that we have to include or build from, which is bigger and much more power hungry than what a super optimized LTE-M and narrowband IoT IP has to be. We also ensure that we support all the power saving modes as they are defined in the 3GPP standards. So even though 81-second EDRX timing is a common benchmark out there, perhaps for the reason that some chipset doesn't support much more than that, our device supports all defined sleep periods for EDRX and PSM as they are defined by 3GPP. The modem also have a GPS included, and it's a scheduler inside the modem that are able to interleave GPS and LTE-M communications on this chipset. This means that you can run both GPS and LTE-M without having to think about any interoperational challenges. You can even run it using the same external antenna, and you don't have to worry about coexistence or other challenges if you run things externally. The modem contains all stacks that you need for connectivity, all the way up to the security stacks on TLS and DTLS, and it supports any external SIM or eSIM. Around 5 weeks back, one of my colleagues, Petter Myhre, had a dedicated seminar, an introduction to LTE-M and narrowband IoT technology. So I encourage you to go back and look into that also if you have more detailed questions on cellular technology itself, which I will not talk too much about in the seminar today. Then we have the application processor, which is part of the same SoC. This is built around an ARM Cortex-M33 CPU, which is the latest, most efficient and most low power embedded CPU from ARM. This also includes what is referred to as ARM Trust Zone, which is a powerful security extension that allows you to build multi-layered security implementations where the application firmware is split into non-secure and secure regions. A typical use case for this is that you handle key management, secure boot, and cryptographic algorithms in the secure region, while all the communication to the outside world through the modem resides in the non-secure regions of your firmware. And this means that it's possible to separate completely the software that manages security-related aspects on your application and all the software that typically contains a lot of stacks and middleware and a lot of open source code in today's world. And by partitioning the application in this way, the device doesn't become vulnerable for over-the-air attacks that typically go after weaknesses that is found in stacks and middleware. Because even if you are susceptible to an attack through stack and middleware, that code are never able to change the security partitioning and the security rules on the device, because that's held by the secure code that reside in a separate part of the firmware. We also added an ARM crypto cell to further enhance the application security here. This crypto cell can perform computationally intensive crypto functions with really minimized power, such as encrypted curve cryptography, RSA, and AES, and more. The device also has a true random number generator, and it has a key storage unit so that you can securely store keys and management. So in total, you have all the tools here that you need to also build good level of security on the application side, in addition to the security that we have on the modem side. With the application processor, there is 1 megabyte of flash and 256 kilobyte of RAM. And there is 4 communication interfaces that can be used for SPI, UART, or I2C, PDM, I2S, 12-bit analog, PWMs, and 32 GPIO. And it's important for you that you take note of that all these resources are completely available to you when you write your application around this application processor. None of these resources are used by the modem. It has its own core, its own memory, and its own security. So when we have built an architecture like this, as a dual-core architecture with an application processor and a modem, it opens up for some really interesting capabilities on the application and how you build your total solution. As I mentioned, you have dedicated resources for each core, dedicated memory, peripherals, and dedicated CPUs. And the modem in this SoC is abstracted for very simple integration. So if you look on the right-hand side, there's a secure BSD socket API between the modem and the application that you use for communicating and configuring the modem from the application side. At the same time, there's really seamless integration between the modem and MCU. Because this is a single SoC, all the clock and all the power management is shared so that you can optimize the whole SoC for lowest possible power, and the modem and the application can sleep and wake up and being synchronized to each other. The secure BSD socket interface between everything that resides in the modem side and what resides in the application side is something that you can set up as really do a lot of things. You have 8 generic sockets here that you can use for UDP, TCP, TLS, and so on, or for AT commands to configure network and modem settings through traditional AT commands. You have sockets to control GPS for firmware updates and a lot of generic sockets that can be used for raw sockets on IPL level, APN configurations, and so on. So that's really a powerful way for you to control the modem from the application in a very standardized interface. Here you also see that for communication, all the stacks up to IP, TCP, and TLS and DTLS are running inside the modem, while all the higher level stacks, all the middleware that you need to connect is running on the application side. And as I will get to later, everything running on the application side that comes from Nordic is open source. So it's easy for you to customize this to either add or remove any middleware or stacks that you need, or to make changes to them to make them fit exactly the device management platforms that you have to use or want to use. So in total, if you look at the application circuits for the 9160, it becomes very simple. You have the SIP, and around it, you need to add a battery, of course, any sensor that you need for the application, a SIM card, and you need antenna for LTE and GPS. These components are external because they are always application specific. Which battery technology you need to use and which sensor you need to use depends on the application you want to build, which SIM that you need, and which antenna that you build will depend a lot on which region you want the product to be placed in, or if you want the product to be placed in a lot of different regions and build a more complex solutions around eSIM and more complex antenna. So here you have the ability to create a very small, very low power product with simple bill of material, where your application is hosted inside the application processor, and we provide all the firmware for the modem together with an open source software development kit that you can use to base your application from. So on the next slide, there is an overview on the software side of the 9160, since all this cannot happen without a lot of software. So all the software that Nordic offer resides in what we call the nRF Connect SDK. And this software development kit has two key parts. It's the modem software. The modem software is a binary that is delivered as closed source from Nordic. This is mainly due to the fact that we need to certify our SIP both regulatory and for carriers or mobile operators. And that certification will be broken if you start to change something on the lower layers here. The other thing is that all these layers up to TLS and DTLS is very standardized. You will need all of this for almost any connected applications. When you then look at the application side and the application processor, everything inside the SDK is open source. And here we have all the key protocol stack and middleware that you need for connection. And we have complete application examples that show you how to connect to the cloud using CoAP, lightweight machine-to-machine, HTTP or MQTT, show you how to do device management, how to do application photo, and how to do modem photo, and so on. This ensures that you have all the building blocks that you need to connect to the cloud, whether you need various types of device management, photo or diagnostics, or you need the application to upload certain data using certain protocols to the cloud. On the hardware side, the 9160 is also simple to integrate and design with. In order to put this onto a PCB and get it to work, you basically need 4 capacitors and 4 resistors plus the antenna and matching circuit for that. So I'm very happy to hear from many of you that integrating and starting your hardware design with the 9160 is as simple as a standard microcontroller and even much easier than a lot of the more complex processors out there. You can do this on a quite basic 4-layer PCB, and Nordic has both guidelines and white papers on how you do your antenna matching and start building your antenna. And we have also done webinars earlier with one of our partners that are antenna designers or antenna manufacturers that teach you the basics on how you go ahead and start working and designing how you want your antenna to be before you go to your antenna manufacturer and define the details together with them. So even this is very good. I know that for some of you, building your complete application inside the 9160 SIP can be a challenge for various reasons. So I want to talk now a little bit about some of the additional features that we have developed over the last quarter to also support other use cases for the 9160. So it's now also possible to use the 9160 as a serial LTE modem. So as a serial LTE modem, you basically connect to the 9160 over a standard UART, and you use a standard AT command set to control everything from a host application, instead of running the application on the application processor on the 9160. And there can be several reasons for doing that. First of all, I know that many of you want to have a quick way of evaluating modems. This can be for feature evaluation, power consumption evaluation, and so forth. Secondly, some of you have applications that, or hosts or hardware that you need to keep. This can be for time to market reasons, or it can be that you have the need for a more powerful processor because you're running different type of stacks, or you have displays or user interfaces and so on that requires a lot of memory. And then it's now possible to keep all those and then still use 9160 with 80 commands. And still you can run stacks and middleware also inside the 9160, as I just showed you in this architecture. It also gives you a possibility to take and spend more time to migrate your host application to the 9160. So if you have really urgent time to market needs for your first cellular product, you can take the 9160 and use it as a modem in the first phase, and then later integrate your code on the same SKU and starting to port over some and more of your function to save power and bill of material versus a split architecture like this. So how has Nordic done this? We have basically developed what we refer to as a serial LTE modem application that runs inside the application processor on the 9160. And this serial modem application will be the interface to the outside world with 80 commands, and will internally translate those commands either to use some stacks already running on the application processor, or 80 command or BSD socket interface to the modem. This serial LTE modem application we deliver as source code as part of the NRF Connect SDK, as I just mentioned. That means that you have very flexible options for how you want to do this. You can basically build it and use it as is with the current feature set that we have for basically connecting LTE, configuring the modem and the network. We have support for CoAP, MQTT, FTP, basically TCP, UDP communication, and so on. Or you can also customize and add other functionality using this SDK. You can add dedicated libraries that is needed for certain device management in certain carriers. You can add FOTA support. You can add your own middleware and your own stacks and still have them as part of the application. And we in Nordic, we continue to add more commands and more features on request from you. This is a very flexible solution because it runs in the application processor, so we are able to very quickly turn around to add features or to customize if you need any custom features, or do any custom work inside the application processor to optimize some of the commands or some of the needs that you have. This serial LTE modem application basically uses one UART and around 10% of the available memory on the application processor, so that you have a lot of memory and resources left inside the 9160 when using it as a serial modem. It's very encouraging to see that some of you are still very happy with this approach, simply because 9160 is very low power, and low power is important for you. So you want to have the lowest possible power modem in your application, and thereby go and select the 9160. But you should really be aware that starting from this, you can add or change features as you want, or you can start to offload your main host and put functions inside the 9160. Typical use cases for that is as I/O expander or for other type of board control, because the main host is typically overloaded with a lot of low-level functions. You can develop low-power sensor hub or offload other smaller functions completely, or you can start to run part of your stack and your middleware on the 9160 instead of your main host to offload it even further, or to save power by integrating some of the stack and middleware for connectivity closer to the modem side. I will talk more about low power consumption shortly, but before that, I will just highlight a couple of nice GPS and positioning improvements that we did now in Q2 this year and that will come in Q3. Since I know that there's a lot of you doing tracking applications with the 9160 today. So we have recently developed what we refer to as cloud-assisted GPS, where you can download assistance data for GPS through our nRF Connect for Cloud. This typically improves time to first fix from around 30 seconds with cold start to below 5 seconds. And when you download the assistance data from nRF Cloud, we have processed and packed those data inside nRF Cloud so that you minimize both the power and the data cost for downloading data. So the normal assistance data that you download from nRF Cloud is around 2 kilobytes in size and valid for 4 hours, similar to as when using the standard SUPL or SUPL protocol that is commonly used today and really optimized for higher power and more powerful devices such as cell phones. We will also in Q3 offer what we refer to as predicted assistance, where you can download a larger packet of data, which is then valid for 7 to 14 days. This means you can have assisted GPS even without reconnecting to the cellular network very often. It can be good for saving power, and it can be good if you know that you have an application that may be out of cellular reach for a period, but you still want to track where the device has been and be able to track location or movement of equipment, persons, animals, and so on. We have also recently done core enhancement to the GPS to improve the sensitivity and lower power. We released our modem firmware 1.2 version now in Q2. So we have improved the sensitivity for cold start up to -145.5 dBm. We have also improved our sensitivity for tracking to -155 dBm. And we have lowered the power consumption in basically all modes, acquisition, tracking, and duty cycling, with between 5 and 10%. If you look at the latest public product specification of the 9160, you can find all the details on the improved GPS numbers there. Then I plan to talk a little bit about low power consumption. This is a very dear topic to me for many years, because if you can achieve ultra low power in your product, you can save battery life, or you can save your customers from changing batteries or recharging the batteries very often. So it's really a key to deploy a lot of simple modules in a big way, I would say, because when you simplify the life for customers, or you can live from a small battery in many, many years, you open up for a lot of use cases where devices are remote and where devices doesn't need interaction with humans due to maintenance. So as I mentioned earlier, when we designed the 9160, we started from scratch and we gave clear objective to the whole design team from the start to build the lowest power cellular IoT solution in the market. We developed the modem from scratch in order to have just LTE-M and NB-IoT and not any legacy support. and to optimize everything in the modem for those two protocols. That doesn't only mean we can optimize for those protocols, we could also optimize power management and sleep modes so that we can very efficiently turn part of the modem to sleep very often, even during RCC idle mode or RCC connected mode, because even though the transceiver is transmitting data, some parts of the modem can still shut off, such as DSP or other features, in order to save power. We have chosen a low leakage process technologies with embedded memories. So everything is embedded on a single die. So we don't have the need for any external memory in order to support very, very low power sleep modes. When we develop the SoC with the application processor and the modem together, we can also take advantage of that when we optimize clock and power management for everything together. And we can optimize the interface between the application and the modem in a way so that you minimize how much data you need to send between the modem and the application. There's no need for the modem here to wake up the application processor in advance to tell it that data is coming, such as you typically do with an external application processor and a standard modem. The modem here can simply wake the application processor as data is coming, and the application processor wakes up very fast to receive those data and start any processing. We know that cellular is still very complex when it comes to power, especially because cellular connectivity has a lot of variables that impact the power consumption of the design. So we also help you as a customer to do power measurements in very particular scenarios that we haven't documented in our product spec yet, or in scenarios that are very important for you in order to calculate battery lifetime in the application. This can be scenarios such as when conditions are really bad, so you need high output power and a lot of repetitions to understand how many of those incidents can you have before it really starts impacting the total battery life of your applications. So here is some key numbers for what is possible to achieve with the 9160 SiP. When we go to system off mode, we are at around 1.4 microamp. Here, MCU is off and the modem is off. But an important thing to notice is that the GPIO is still retained and keep their state. So you don't actually have to disconnect any external circuitry in any graceful or non-graceful way because you lose power on the I/O. So that makes things very much simpler than a lot of other modems out there that turn off all the GPIO retention when it goes to deep sleep. And by doing that, you lose control very easily of external circuitry, and you have to reinitialize a lot more when you wake up. The PSM floor current when you are in PSM sleep is 4 microamp, giving you an average power consumption with 1 hour cycle on PSM and an active timer of 20 seconds, only 12.5 microamp. This includes also the SIM card, because our device by default will turn off the SIM when it can in order to save power. It will not leave the SIM on. And in these sleep modes, another thing to remember is that the modem and the application is fully retained. So you don't have any huge boot up power cost here in order to reconnect to the network or reinitialize your operating system and the application. They can basically boot up in microseconds and start running exactly from the same point from where you went to sleep, since all the stacks and all the memories are retained. This is very powerful because when you do not sleep for very long, that will say you sleep for a few hours or even up to a couple of days. If you lose retention on the modem side and you completely disconnect from the network and you need to really reinitiate your connection from scratch, it's a huge power surge on your batteries. So it's always more power efficient to stay retained for as long as possible, all the way up to probably a few days before you're considering going to any system off mode or any very low power PSM mode that others offer, where you actually lose retention of the whole system. So if you compare our nRF9160 to other modules that are typically used in cellular IoT applications, you can see that, as I mentioned, when you are in PSM and you are retained to avoid very long and very power-hungry wake-up times, our power consumption is almost 90% lower than other modules out there. Because we retain power and we have a very efficient wake-up cycle, and we can wake up very quickly, our what we refer to as boot event when we go from PSM into active mode again is also extremely low power consumption. If you go to EDRX, which is a useful sleep mode if you are sleeping for a shorter time or you need to be available so that the network can send you some data, we also achieve only 19 microamp in average, including the SIM card, with 1 minute and 20 second EDRX time. Looking at active mode, when you are transmitting data at 23 dBm power, you start to see the full potential of building a cellular modem from scratch that is optimized for narrowband IoT and LTE-M. We can do that at band 13 with typically 105 milliamps in total, which is 40 to 60% lower than other modules out there. This has to do with very optimized transceiver design, very optimized front end. We started all the front end work, all the system and package work in parallel with building our SoC. And we also have a modem architecture where the DSP is very efficient, and then part of the modem can go to sleep basically all the time when it doesn't need to operate to very efficiently save power also during active cycles. You combine this with the fact that we have a low power application MCU that's available for you to develop on, and an embedded software development kit with a lot of source code and reference code to build from. You have all the building blocks in place to create a very, very low power cellular IoT solutions based on the 9160. I'm also very happy to tell you that we are going to offer or announce some very significant power improvements on the 9160 very soon. We have optimized the power management and lots of things around the SIP to improve basically all our numbers from what we have today. So when it comes to lowering power consumption on a cellular device, there's an important thing I want to also talk to you about today, and that is how you can lowering power by utilizing edge computing. So when you have a device like the 9160, which has a good deal of computing power and memory available for your application, you can use that to minimize how much data you're sending to the cloud or to your servers from the 9160. Inherently, LTE radio transfers are expensive when it comes to power. As I just showed you, when we send data, we are typically at 100 to 150 milliamps, when a lot of others are at plus 200 milliamps for sending data. In addition to that, you have subscription fee, of course, where you need to pay for the data, which also add in. If you then look at the cost of processing data on the 9160, you can process data at 30 to 50 times lower power consumption than sending the data. So when you are designing your application, be very conscious about sending information to the cloud and not sending a lot of data to the cloud. When you connect sensors and start getting data from sensors, they typically send out a lot of data. An accelerometer can send continuously 3 times 16-bit values every 100 milliseconds. In the application, you want to use that to understand what's going on. For example, that the thing has fell over sideways, laying flat. And if you're able to make those calculations and those decisions inside the 9160 before sending it to the cloud, you don't have to send a lot of data, but you can send 1 byte of information, which actually is that something has happened and the thing fell over. At the same time, when you design your application, you need to understand enough of your application to build in some way for the application to understand when something interesting has happened. So when you connect sensors to your application and you analyze your application requirements, there is a typical behavior and a typical response from those sensors, and there's perhaps some non-typical response. So the accelerometer will typically send out very, very limited data if there is no movement, and it will send a lot of data when there is a rapid movement and the device is falling over. But there could be windows of values that are interesting to send if there is the accelerometer is suddenly starting to send data indicating that there is some type of movement, but you can't really understand why. So if these situations occur, your application should also be clever enough to send some additional data to the cloud, because in the cloud you have a lot more processing power available, so you can actually analyze and find patterns to further optimize your application ahead in time by, for example, building in new rules for when information should be sent and when the information shouldn't be sent in order to save data. Those rules can be updated dynamically if you build an application for that. But the 9160 also support full firmware over the air of the application. So you can also upgrade your complete application in the future if you have built an application that are more clever than what you have today. We have also recently launched what we believe is the first online power profiler for cellular devices. So we have an online power profiler for the 9160. Here you can go and select a lot of settings, what network you want to use, what are your sleep interval, what is the output power, what data payload do you want to send, how often do you want to send those payloads, and so on. And then real time, you will get a plot that shows the estimated power curve for the device, including all the peak currents when you sleep, when you're awake, when you're transmitting data, and also the average power consumption that you have on your device. So this is a good way to do an initial evaluation of power consumption for an application, testing out various sleep periods, various payloads, and different LTE technologies, various output powers, and so on, to understand the basics. But of course, such a profiler doesn't account for anything that can happen inside the network. So once you have done this and you have the basic configuration that you think you want to use, then you should go on and test this in a live network. And of course, if you have any questions or if you need help to optimize that further, you are free to contact Nordic and we will support you in that. So I hope this will become a very valuable addition for all of you that want to develop low power cellular product, to quickly have a way of understanding what is actually the power consumption when you try and add cellular connectivity to your applications. So with that, let's talk a little bit about development tools and status on the certifications before we go to the Q&A. So starting with development on the 9160, there's two key things that you need to have. You need a development kit. We have two kits today that come preloaded with firmware so that you can, out of the box, get cloud connectivity without having to write any software or compile a single line of code. And then we have what we refer to as the Nordic nRF Connect suite, which is a set of tools that you need to have in order to develop your cellular application. We have the nRF Connect software development kit. So in here you have all the middleware, real-time operating system, hardware drivers, and sample applications that you build your application from to fit inside the 9160. Then we have the nRF Connect for desktop. So this is the desktop tool that you download, where you have your IDE, you have the compiler, you have a getting started assistant that show you how to get started with development, and you have various tools that you can use to program, to do monitoring of LTE, to do trace, and so on. And the last thing that is very important is nRF Connect for Cloud. This is Nordic's cloud solution, where you also have examples on the cloud side, how to do device management, you can do SIM management, you can configure your device, and you can reprogram your device over the air using your cloud account. So on the kit side, we really have two kits on the 9160 today. We have the Thingy 91. This is battery powered, really size optimized. And here you can program both the modem and the application over USB. And then we have the 9160 development kit, which is mains powered, but also have expansion headers. So it's more powerful if you wish to do your own development on the hardware side and connect some specific sensor, connect a host, and things like that. This also includes on-chip debugger with USB connection directly on the PCB. So here you can also do not only programming of the modem and the application, but you can also do on-chip debug as you develop your application. So it's a more powerful developer platform versus the Thingy 91, which is a powerful evaluation platform or prototyping platform. Both comes with a SIM card from iBasis that is loaded with 20 megabytes of data. And they come with a getting started guide so that you can also get it connected to nRF Cloud via simple configurations before you start any actual developing or try and compile any code on your own. So both the 9160 and the development kit comes with a lot of sensors on the PCB, MOSFETs, LEDs, and other features that you need to do basically some prototyping and application prototyping. The full hardware design is available from Nordic as open source, so you can download all this as well to start your hardware design based on our DK or our Thingy 91. You should be aware, however, that we have designed an antenna which is quite complex because we want this product to work worldwide in all the different bands that are available around the world. So if you want to design a product that fits certain part of the world, so you only need to support 2 or 3 or 4 different bands, you should really work with your antenna manufacturer, create an antenna design that fits your application requirements in terms of size and in terms of bands, so that you simplify your design as much as possible. And as I mentioned before, we did a webinar earlier with Fractus, one of our antenna partners, on how to start embedded antenna development for cellular. So I really encourage you to look at that also if you are interested in how you can get started on the antenna side. So one quick peek inside the software development kit for the 9160. So inside the SDK, you have our low-layer firmware, including bootloaders and device drivers. We have a real-time operating system called Zephyr, and with Zephyr, all the middleware and all the stacks that runs on top of Zephyr, together with all the system management that you will need to run an operating system with all the device drivers. And on top of this, we offer an application framework and also complete reference design for complete application, such as an asset tracker or the LTE serial modem. Everything is available for free. It's open source, and it continuously developed and improved. And even though this is open source, we tag it as we refer to. So we release a new tag with new tested and verified features around once every quarter. And on all these major tags, we give lifetime support for fixing bugs or critical issues that is discovered later. So you have the same support on this SDK as you will traditionally see for a binary. All this is hosted on GitHub, so it's publicly hosted, and version control. So you can either work from a tagged release with lifetime support if that's important for you, or you can work directly from our master branch, where you continuously get access to new feature and new improvement as we develop them before we tag all these features once they are through our testing roughly once a quarter. So very quickly on how you get started on the 9160. Get hold of a kit, either on Thingy 91 or a DK that you wish to use. One thing that is very important to notice is that there is no global roaming agreements yet on Narrowband IoT. So if you are somewhere in the world where you wish to use Narrowband IoT connectivity, you should order and get hold of the local SIM card that you wish to use, because we are still waiting for global Narrowband IoT roaming agreements to come in place. There is good things happening now. We see some major carriers announcing Narrowband IoT roaming agreements. So hopefully a global agreement is very, very close, which will solve this little challenge that we all have. Secondly, you need an account or an nRF Connect for Cloud. When you have that, you can unpack your kit and you can get connected by following a very basic step-by-step guide. When you have done this, you can configure and you can monitor your Thingy 91 or your DK without having to recompile or develop any code yet. Once you want to start developing, you need to download nRF Connect for Desktop and install the toolchain manager. And once you have done that, you have this getting started guide that will install the toolchain for you with the IDE and the compiler, and that will install the nRF Connect SDK for you from GitHub, either the master branch with all the latest features or tagged release that is tested and guaranteed with support if you are close to releasing your product to production. When you've done this, you are really set with all the basic tools that you need, and you can dive into that either with our getting started guides, our videos, and more seminars to understand how all the protocol and all the stacks in the SDK work and how you can start developing your own application. So then quickly ending with a short status on the certification side. So on the regulatory, the most important thing is that we have now completed regulatory for China this quarter. So we have completed all the major regions that we initially have targeted for 9160. There is still regions in the world we don't have regulatory yet, and we are continuously evaluating that. So that if you need that, and if you have the needs, please talk directly to our regional sales manager, and all those requests are pipelining to me, and we evaluate and prioritize how we move forward next with other regions. On the carrier certifications, our most recent accomplishment now in Q2 was Telstra in Australia. So we have now completed certification for Verizon in USA, Vodafone and Deutsche Telekom for Europe, and Telstra in Australia. We are then working with a lot of additional carriers, so we will more than double this list by end of 2020, with several carriers in Asia, with additional carriers in USA, with carriers in Canada, and more. So that map of carrier coverage will also become very, very complete by end of this year. I talked a lot about how we developed a low-power solution from scratch in Nordic. So before I end, I want to make a very important point around that. We developed really a low-power solution from scratch, but we didn't start from scratch in Nordic. We hired 100 very senior guys from a cellular center in the world, Finland, and we are now growing that team to be more than 150 people, and we have more than 2,000 man-years of expertise in cellular in Nordic. So as you hopefully understand, even though we have our first cellular product, which is a very, very powerful product in terms of features and low power, we have a very, very experienced and senior team so that we can continue to build the feature set and improve in the future also for future products. So thank you very much. That was what I had to present today. I will then go to the question section and spend the last minute to answer those questions that I see that are most relevant for this session today. So there is a question if power management is integrated inside the 9160, and the answer to that is yes. There's a complete power management ICs inside the 9160. You don't need any external power management ICs as long as you respect the maximum input power of 4.5 volt or 5 volt for the 9160. There's a question on which RTOS that is used. So mentioned in the presentation, we use Zephyr, which is quite recently developed, but very powerful open source RTOS. There's a question on migrating to or from the nRF52, so Bluetooth Low Energy, to the 9160. These are not pin compatible today, so I think the best way forward, if you want to understand more, especially on antenna and other components, is to go to DevZone and ask Nordic directly, and we will provide you with a starting point how you can port your design. The good news between our Bluetooth Low Energy devices and our cellular device is that the Nordic Connect SDK, we are continuously now adding our most recent, but also will add more legacy nRF5 devices to that SDK, so that you will see now that our cellular and our short-range Bluetooth Low Energy devices, they will all be part of the same SDK. So you will have the same code base for all devices in the future, whether it being a cellular device or a short-range Bluetooth Low Energy device. And then there's a question whether you can still run GPS when completely turning off the LTE. That is correct. If you completely turn off the LTE, the GPS is still available and you can run it. And you can then use assisted GPS, as I talked about, in order to get assistance data to the GPS. Then you can start a GPS, and the GPS will basically go out and ask for time of week from the satellites, and you will have a fix. So that's a very easy way to get fix. But you need then to have these location data either available by downloading from LTE or this offline support that I mentioned that we will release in Q3. Then there is a question whether there's a plan to enable concurrent GPS and LTE on the 9160. The 9160 is built so that GPS is always interleaved with LTE in order to optimize the design and in order to ensure that you can use one single antenna without any coexistence challenges or design challenges. So we will not enable concurrent GPS and LTE on the 9160. Then there's a question whether we plan to support lightweight machine-to-machine. Lightweight machine-to-machine is something we support already today. We have version 1 compliant lightweight machine-to-machine implementation that is part of the Zephyr lightweight machine-to-machine. There is a lot of traction on the lightweight machine-to-machine for the time being, so we are also investing more resources into building our plan to continue to develop the feature set and have a lightweight machine 1.1 compatible solution sometime in the future. Yeah, and then there's a question whether our system and package support narrowband IoT, and yes, this is both narrowband IoT and LTE-M. So if you want to understand how power efficient this is in narrowband, I advise you to look at our product spec that you can download from nordicsemi.com, and you will find a lot of the power characteristics for the narrowband IoT also documented inside the product spec. There is a question related memory usage on the SIP for a specific use case with data. I advise you that in general you have 1 megabyte of flash and you have 256 kilobyte of SRAM available on the application processor. Some of that is used for the BSD library and for the secure boot and so on, but most of this is available for your application. So try with that information, make your calculations, and if you don't figure it out, please contact our technical support on DevZone. Then there's a question whether we plan to add the GPS usage and other features into the power profiler that we have online. We plan to do that. This is the first release. So based on your feedback and the needs, we will continue to improve this to support more complex use cases in the future. Yeah, and then there is a question regarding iBasis and the lack of PSM sleep mode support for iBasis. So unfortunately, the situation today is that the big carriers, they limit some feature sets for the MVNOs in some parts of the world. So this is something that you should also go and get push onto iBasis on to try and improve. We are also working close with iBasis and the big carriers to try and make them open up to also support sleep modes with virtual operators. But if evaluating and using PSM is very important for you and you don't have support with iBasis, our current advice is that you get a local SIM card. And then there is a question about certifications for Vietnam and Japan. We are planning for that. I cannot share more detail today, but we do plan to have coverage by end of this year. There's a question whether we will support Google Cloud. There was also some questions on Azure further down. So today we support AWS, Amazon Web Services in our SDK, but we are continuing to build support for other cloud services. So shortly we will have support for Azure, and we plan to certify that, and then we plan to build support later this year for Google Cloud and also other major cloud services. Then there's a question whether we plan to have a power profiler board like we have for the 9120, and that's the answer to that is yes. We do, hopefully by end of Q3, also launch a power profiler board that is compatible with the 9160 DK and the 9160, so that you can do real-time power profiling also on your hardware with the 9160. And then there's a question whether there is a low power mode for GPS, where you can rely on GPS time instead of using an RTC. That is a feature that we plan to develop and hopefully have available in Q1 next year, so that you can rely on GPS time instead of other time, both for low power but also for synchronizing several devices in the network with the same time from GPS. Okay, that was most of the questions that were relevant for this webinar. If some of you have other questions or you feel that you need more details, please get in touch with us using DevZone. Then I would like to thank all of you for listening to the webinar today. I hope this was useful. I hope it gave you a good overview on the 9160 and the capabilities, so that we in Q3 and Q4 will move forward with more in-depth specific webinars for the 9160, focusing on various parts of stacks, connectivity, and low power aspects that need more time and go more in depth. So have a good day and have a good evening, and hopefully I'll see you all soon again on a webinar from Nordic. Bye-bye.